Hey guys, Mrs. Hilscher here. Today is the second lesson in geometry. We are going to be looking at triangles today. So first let's look at a couple of different types of triangles. So we'll do a quick review of what triangles are. Okay, so we know that triangles are three-sided figures. They have three angles. But let's look at certain types of triangles. So the first one, if you remember, is, scalene. And as I'm doing this, try to remember before I say it what these triangles are. So if you remember scalene, a scalene triangle is a triangle that all the sides are different lengths, so that has no congruent sides. Alright, the next one, isosceles. Alright, an isosceles triangle is a triangle that has two sides that are the same length. Okay, has two congruent sides. Alright. Equilateral. Right, that is a triangle where all three sides are congruent. Okay, pretty common one, right triangle. Okay, it's a triangle that has a 90-degree angle. Alright, so the other one is an equal angular. I'm going to write that out. Right, equal angular means that all the angles are congruent. Okay, but if all the angles are congruent, that also means that all the sides are congruent. So an equal angular is the same thing as an equilateral. Okay, so let's talk about our first theorem with triangles. Okay, it's a pretty common one. Everybody should know this, but if not, take notes. Remember, THM means theorem. Okay, so our first theorem is the sum of the measures of the interior angles of any triangle is 180 degrees. Meaning if I add up all three angles, if I add up all three angles of a triangle, it should be 180 degrees every single time. So let me write that up. Oops. hold on. Okay, so 180 degrees, and this is for any triangle. So let's look at an example of how we could see this problem written, or this type of problem. Okay, so we have a triangle A, B, C. Say angle A is 42 degrees. Say angle B is 63. And I want to know what angle C is. Okay? So how would we do this? All right, knowing the theorem that the angles equal 180 degrees, we could just add angle A, the measure of angle A, plus the measure of angle B. Okay, and then subtract that from 180 degrees. So let's do that. So 42 plus 63 gives us 105 degrees. So then we can subtract that from 180. And that gives us 75 degrees. So the measure of angle C equals 75 degrees. Okay, let's look at another example. Right, so in this example we have, again, triangle A, B, C. Okay, and in this triangle we're going to say the ratio of the angles is 1 to 2 to 3. Okay, and that just means that we'll say that A is x, then B would be 2x, and C would be 3x. Okay, they're a 1, 2, 3 ratio. Okay, so if I asked you to find the measure of each of these angles, so we're looking for a measure of angle A, measure of angle B, and measure of angle C. Right? Using the theorem, the previous theorem, that each of these angles adds up to 180 degrees, we could set up our problem. So add each of the angles together. X plus 2x plus 3x equals, well, 180 degrees. It has to. Okay, so what do we get? We have 1x plus 2x plus 3x. So that gives us 6x equals 180 degrees. We have a simple problem. Now we can divide by 6. Okay, and solve for x. Right, 180 divided by 6 is 30. Right, so that tells us what angle A is, because angle A was x. So angle A is 30 degrees. Okay, angle B is 2 times x, so 2 times 30, 60 degrees. And then angle C is 3 times x, or 90 degrees. Okay, and if you add those up, 30 plus 60 plus 90, you'll get 180 degrees. Okay, let's move on to our next theorem. And guys, remember to pause or rewind the video as much as you need to, and please be taking notes. Okay, so this next theorem is about isosceles triangles. Okay, okay, so this says if two sides of a triangle are congruent, the angles opposite those sides are also congruent. Okay, those two angles are called base angles. Right, so if we have this triangle here, and I said that this side was congruent to this side, and that's what those slash marks mean. It means that those two sides are congruent. So if I say that those two sides are congruent, the angles opposite of them, so we have this side, opposite of this side is this angle C, opposite of this side is angle B. So angle C and angle B would be congruent as well. Right, and those are what are called base angles. The base angles are congruent. Right, so if side AB is congruent, remember this symbol means congruent, to side AC, then angle B is congruent to angle C. Okay, so let's look at an example. Right, in this example, we're going to be solving for x, or finding x. Sorry, crooked looking triangle. Okay, so in this example, we are given a triangle ABC where angles B and C are equal to each other, or they're congruent. Okay, so right off the bat, I know that this is an isosceles triangle because two of my angles are congruent. That means that two of my sides are congruent. So this side and this side are congruent. If they're congruent, that means they're equal to each other. So I can just take 6x minus 8 and set it equal to 4x plus 2. Alright, and now we can solve for x. Subtract 4x from both sides. Okay, that's a negative 8, so we're going to add 8 to both sides. And then divide by 2. X equals 5. Okay, let's look at another example with this theorem. Okay, so in this example, we're going to find the measures of angles 1, 2, 3, and 4. Okay, so alright, so in this triangle right here, we see that it's an isosceles triangle because these two sides are the same. And we know that one angle is 50 degrees. Okay, these two angles, angle 1 and angle 2, have to be congruent because this side and this side are congruent. Right, using the theorem that base angles are congruent. Right, knowing that, we can figure out what angle 1 and 2 are because we already know what one of the angles of the triangle are. This requires that we use both theorems that we've gone over so far. So the first theorem was that a triangle's interior angles add up to 180 degrees. So if we say 180 minus that 50 degrees right here, what are we left with? We're left with 130 degrees. Okay? These two angles, that means that these two angles add up to 130 degrees. However, they're the same, so we can just divide this 130 by 2. And that gives us 65 degrees. So angle 1 is 65 degrees, and angle 2 is 65 degrees. Okay, halfway done. Alright, now let's look at this triangle right here. It says that this side and this side are congruent. Okay, knowing that these two sides are congruent, the base angles have to be congruent. So this angle and this angle, the opposite angles. Okay, so if this is 40 degrees, that means that angle 3 also has to be 40 degrees. Right, well if we know those two are 40 plus 40 is 80, so angle 4 has to be 180 minus 80, which would be 100 degrees. Okay, so now we're going to talk about something that's called a mid-segment of a triangle. Okay, mid-segment. Right, the mid-segment also called the midline is a segment joining is a segment joining the midpoints of two sides of a triangle. And if you don't remember from previous math classes, midpoint of a segment or midpoint of a side is exactly what it sounds like. It's the middle of the segment or the middle of the side. So if we have this triangle, right, so we'll say this is A, B, C, and this point here is E, and this point here is F. If I said that E is the midpoint of CA, that's the middle point, and F is the midpoint of AB, the segment that joins those 2 points together is the mid-segment. Okay, which means that this side is congruent to this side, and this one is congruent to this. They are congruent to each other. Okay. Alright, so there are 2 properties about mid-segments that we need to remember. Okay, the first one is that the mid-segment is parallel. I don't know why it keeps doing that. It's parallel to the third side of a triangle. Okay, what do I mean by that? So we have this triangle, right? This is the mid-segment. It means that this mid-segment is always going to be parallel to the side of the triangle that it's not touching, the third side. Okay, these 2 will always be parallel. Alright? Alright, the second, sorry about that. The second property of a mid-segment is that the mid-segment is half the length of the third side. Okay, so again, if this is our triangle, we say the mid-segment or the third side is 10, it means the mid-segment is 5. Alright, so let's look at an example. Okay, so in this example, we are going to find the diameter. Excuse me, I don't know why I said diameter. I meant perimeter of the outer triangle. So we're going to find the perimeter of triangle A, B, C. Okay. We're going to do that because we know the mid segments of triangle ABC. Okay, remember that if DF, DE, and FE, so DF, DE, and EF are mid-segments. Okay, that means that DE is parallel to AC, DF is parallel to BC, and EF is parallel to BA or AB, whichever one you want to call it. Okay, so if that's true, that means all we have to do is double each one of these mid-segments to get the length of our sides of our bigger triangle. Okay, so 8 times 2, 16, 7 times 2, 14, 6 times 2, 12, and then of course perimeter is adding each of the sides together. So 12 plus 14 plus 16. Okay, which gives me a perimeter of 42. Alright, the last theorem that we're going to talk about today talks about an exterior angle of a triangle. Okay, the measure of an exterior angle of a triangle is equal to the sum of the two non-adjacent interior angles. Okay, so we have angle 4. So if we look at this, we have 4 different angles here. Okay, the only one of these angles that's exterior means the outside, is angle 4. Angle 4 is on the outside of this triangle right here. Right? So this triangle has 3 angles. 1, 2, 3. The 2 angles that are non-adjacent means not touching. They're non-adjacent to the exterior angle. those two angles would be angle 2 and angle 3. They are not touching angle 4. So that means, according to this theorem, that the measure of angle 4 is equal to the measure of angle 2 plus the measure of angle 3. Right? So if you're trying to find this angle on the outside, you go to the two angles on the inside that are not touching that angle and you add them together. So let's look at an example. Right, so we have alright, so here we have a triangle, and we have this exterior angle of 140 degrees, and then we have this angle right here is 45 degrees, and then we're trying to find this angle here. Okay, even though it kind of looks like a 90-degree angle, but it might not be. Okay, so we know that this angle is equal to the sum of these two angles. Okay, so real quick, all you have to do is 140 degrees minus 45, right? That gives us 95. So this angle is 95 degrees. 95 plus 45 gives us 140 degrees. Alright, and that's it for triangles.